Okay, guys, we're going to start section 10.2, which is arithmetic sequences. And you already seen this in Algebra 1, but we're going to go through it again. It's a sequence in which each term after the first differs from the preceding term, the previous term, by a constant. The difference between the consecutive terms is called the common difference, which is going to be a lowercase d of the sequence. So I have three examples here of arithmetic sequences. So really, it really is, are you adding or subtracting to go from one term to the next? So you could see that you're adding 4, all right, to get from 142 to 146, 146 to 150. It differs by a constant. In this case, it's a positive 4. So in this case, D would be 4, the common difference. Well, how do you get D? Well, really you got A1 plus some number to equal A2. So here's A1 and here's A2. So you can always find D by going, subtract A1 on both sides, the second term minus the first term. So you could have found it by going 146 minus 142 to get 4. But it's also got to be consecutive throughout the whole pattern. So obviously you can see you add 4, you add 4, you can just go right to D as 4, but sometimes it gets a little different. So you can always find D by going A3 minus A2, which is your third term minus your second term. All right, we can do the same thing. To get from A2, you're going to add D to get to A3. Well, D is going to be A3, your third term minus your second term. So that's going to give me 4. Now, does it go? It's got to be the same. A4 minus A3. So let's see. A4 is 154 minus 150. And you get 4. Now, maybe you didn't need to do this, but this is an arithmetic sequence with a common difference of 4. Now, when you look at this, it gets maybe a little confusing. Maybe you could see, like, wow, how do I go from -5 to -2 and to positive 1 to 4 to 7? Now, maybe some of you just looked at the tail end here and said, okay, I'm adding 3 because your fear of fractions and negatives are just coming about. But you could do the same thing. To find your common difference, you take the second term and subtract the first term. Well, when you subtract a negative, it turns to positive. -2 plus 5 is 3. And if I did 1 minus, I should get the same answer. D has to be 1 minus the previous term, which ends up being 1 plus 2, which is also 3. And then maybe from here you could say, okay, you add 3, you get 4. You add 3 to 4, you get 7. And here the common difference is 3. Well, the same thing's true here. What am I adding to get to the next term? Because that's your common difference. So you might say, well, I'm not adding, you're subtracting. Well, when you think of common difference, think of subtracting as adding a negative number. So again, I could do this formula here. D equals A2, which is 3, minus your second term minus first term. Minus 8 is -5. All right, well, does that keep going? What is your third term minus your second term? -2 minus 3, well, that's also -5. And -7 minus a -2, well, that's -7 plus 2, is also a -5. So here we have a common difference that is a negative, which really means you're subtracting 5 to get to the next term. So in these two sequences, these are arithmetic, and you can see that this one is actually increasing. So my common difference would be second term minus the first term. Well, that's -2 plus 5, which is 3. But then you want to check. If I add 3 to -2, I get 1. 1 plus 3 is 4. 4 plus 3 is 7. So if you keep adding your common difference, you can kind of figure it out the first and then see if it works all the way through. But I could go, all right, what is 1 minus a -2? 1 minus -2, that gives me 3. What is 4 minus 1? Well, that one's easy, 3. So you see, you get the same pattern. It means you're increasing by 3. So when we plot this, this is going to be a discrete graph. Our domain is your term number. So this would be A1, A2, A3, A4, and A5. So your first term is -5. Your second term is -2. Your third term is going to be 1. your fourth term is 4, and your fifth term is 7, and it keeps going. So what you're going to notice here, if this was a perfect graph, is that all these points are collinear, which means they actually form a line for arithmetic sequences. And if you think about it, your common difference is actually going to be the slope of the line, if you want to look at it that way, because you're going up 3 terms, up 3 for every term. Up 1, 2, 3 for every term. Rise over run. 1, 2, 3 over 1. This is definitely not lined up right. So when you have a positive common difference, you actually have a positive slope. Now here, what's your common difference? D is 3 minus 8, which is negative 5. D is negative 2 minus 3, which is negative 5. Got the negative. D is negative 7 minus a negative 2, which is negative 7 plus 2, which is still a negative 5. So we're going down by 5 every time. But if I had a plot for B, this would be my first term, B1. So my 1 is going to be 8. B2, and I got to use B now because this is the set of the B sequence. That's going to be 3. B3, or your third term, is negative 2. B4, your fourth term, is negative 7. And B5, and it keeps going down, is negative 12. And you can see that these are collinear, and your slope would be negative 5. Down 5 for every term. Down 5 for every term. Down 5 over one term. And this pattern would be collinear with that. So not only do the arithmetic sequences form a linear path, they will also be written in equations that look like lines if you write an explicit formula. All right? So if we were to do recursive formula, well, what you would see for a recursive formula, whatever it is, your first term is going to be the term before. Whatever term you're looking for is the term before plus your common difference. And that's going to be every arithmetic recursive formula because you're really just adding your common difference to the previous term to get your new term. Whether it's this as being A1 is 8, then your second term would be 8 plus a negative 5, which would be 3. Your third term would be the previous term, 3 plus a negative 5, which is negative 2, and so on. All right, but that would be the recursive formula for any arithmetic sequence. Explicit formulas are going to be written as linear equations. So here we are in example 1. It says write the first 6 terms of this arithmetic sequence, and they really didn't need to tell me it was arithmetic. I can tell by just looking at it. All this tells me is I'm subtracting 2 from the previous term. And they do tell me in a recursive form what the first term is. So if I got to find the first 6 terms, which seems like a lot, but the math is kind of simple, I already was given the first term. So to find term 2, we go, remember this is the previous term, so that's A1 minus 2. So that's just 6 minus 2, which is 4. And when I find A3, that's the previous term, which is A2 minus 2. Well, A2 was 4. 4 minus 2 is 2. So I already got A3. A4 is the previous term, which is A3 minus 2. Well, A3 is 2, and 2 minus 2 is 0. All right, and now I got to find A5. Well, A5, that's 5 minus 1, which makes that the previous term, A4 minus 2. So the term of A4 is 0, and 0 minus 2 is negative 2. And then A6. A6, well, 6 minus 1 is 5, so that's the fifth term minus 2. Well, the fifth term is negative 2 minus 2, which makes the sixth term negative 4. So my final answer is going to be 6, 4, 2, 0, negative 2, negative 4. And you can see, like, wow, I'm going down by 2 every time. Well, the common difference is going to be a negative 2. All right? And you can tell that because even though that's minus 2, you can rewrite this as A sub n is A sub n minus 1 plus a negative 2. And I look at it this way because for recursive formulas, A sub n equals A sub n minus 1 plus D, where D has to be plus some number. So since it was minus, you got to look at it as what are you adding? And you're adding a -2 there. So D would be -2, but you can tell that by going 4 minus 6, -2. 2 minus 4, -2. 0 minus 2, -2. So the pattern is going down by 2, which means you're adding a -2 here. So try checkpoint 1. So now we get into the general term of an arithmetic sequence. Now really, we just did example 1, which was dealing with recursive. And we know we'd rather do the explicit formulas. Well, this is how we can get an explicit formula. Okay? Now, to do this, we need some data here. And to do this, it's almost like you want to write in terms of y equals mx plus b, where you need to know what m is, which is your common difference, and b. Now, that's a y-intercept, but that y-intercept is not going to be your first term. All right? Because your first term, if you remember on the graph, starts when it's 1, not your y-intercept. All right? So this y-intercept is not your first term. That's one of the common mistakes that I'll see. But what do these letters mean? Well, a sub n is the last term, or, and it depends on the wording of the problem, or the term you're looking for. So I should say, the value, let me rewrite this, the value of the last term or the term you're looking for. All right, that's a big one there. All right, it all depends on the wording of the problem. N, or a sub 1, is your first term, not the y-intercept, but your first term. N is the number of the term. So if I'm looking for the 5th term, n is 5. And a sub n is what the value of that term is. And D, we went over before, is called the common difference. That's what am I adding or subtracting to get to the next term. So, all right, and that's really what we're looking for. So let's look at example 1. Find the 8th term, example 1. Find the 8th term of an arithmetic sequence. All right, find the 8th term of an arithmetic sequence whose first term is 4 and whose common difference is a -7. So when looking at this one right here, I'm like, all right, there's 2 ways you could do this. One, you can actually, in this question, you can find the value right off the bat. I'm going to show you both ways. The first way I'm going to show you, though, is a little longer, but it's going to be helpful later on. You're going to first find an equation to represent this pattern without looking for the 8th term right off the bat. So if I'm looking at this, the 2 things we need are the first term, which in this case, A1 is 4, and the common difference is -7. So I'm going to set up an explicit formula that can find any term. So I'm going to go a sub n is a1 plus n minus 1 times d. So the only values I know are 4 for my a1 and -7 for my common difference. So to write an explicit formula, I'm going to simplify this as much as possible. I'm going to distribute this -7 through. So it's 4 plus, I should just go -7n plus 7. And now, if I write this as a line, -7n plus 4 plus 7 is 11. Now, you can see that this is my y-intercept, but that's not my first term. That's my first term. But if you think about a graph, your y-intercept would be here at 11. Then your slope is down 7 over 1, which would be right at 4. And that's my first term. All right? Now, this asks me for what's the 8th term. So if I wanted to, I could say, all right, use this explicit formula, -7 times 8 plus 11. So that's -56 plus 11, which is -45. And that would be my value of my 8th term. All right? And we can find the explicit formula that works for all terms. So if they said find the 8th term, the 12th term, and the 30th term, I would write the formula first and then find a 8. That means the 8th term is this. This is the value of the 8th term. And then I would do the other numbers as well. But in this case, I already know that A1 is 4, D is -7, and I'm looking for what is it when N is 8? What is the value of A sub 8? That's what I'm looking for. So if I wrote this formula out, A1 plus N minus 1 times D, we could do this a little separately in just this case. What is the 8th term? Well, A1 is 4. I'm looking for the 8th term, minus 1. And then the common difference is -7. So that's 4 plus 7 times -7, which is 4 plus a -49, which is just 4 minus 49, which gives you -45. And because of the way this question is set up, we could just use this to get our answer of -45. But we could use the write as explicit formula first, which we will practice, and then find the value of the 8th term. But in this case, we could have put it all in one sentence right away to find that 8th term. But if it asked me to find a 10th term, well, then I would have to do this for the 10th term or the 15th term, where if I write it as one explicit formula, it's right there. I'd like for you guys to try checkpoint 2. Okay, so in example 3, according to the National Education Association, teachers in the United States earned an average of $44,600 in 2002. Now remember that this textbook was made in 2000. So this is, or 2001, I forget which one. This amount has increased by approximately $1,130 per year. Now, we're going to play this game, but really teacher salaries along with salaries of where you're going to be don't increase by like arithmetically. It actually increases geometrically. The reason why is because you get percentages for raises. You don't get set increment raises. You don't want set increments. You always want percentages to go up, all right? That creates an exponential pattern, not a linear pattern. But let's get back to this and play the game. So they really tell me what a teacher makes, the average teacher in 2002, and it increases by this much every year. So if it increases like that every year, what that tells me is that the common difference is going to be $1,130 per year. It also says write a formula for the nth term in an arithmetic sequence that describes teachers' average earnings n years after 2001. So I look back and said 2001, this says 2002. Well, think about this. N years after 2001, so what's 1 year after 2001? 2002, which tells me A1 is going to be 2002. So that's value. Well, that's going to mean the year 2002, which the value is $44,600. Okay? So your common difference is going to be this, because this is what increases a year. And this is going to be A1, because your first year after 2001 is 2002, and it gives you this right here. So if I got to write a formula for an arithmetic sequence, it's A sub n is A1 plus the quantity of n minus 1 times the common difference. So I already know that this is my A1. All right? Plus n, I don't know n yet because I'm going to write it in terms of n, the nth term. The common difference is $1,130. So I'm going to first distribute this and go 44,600 plus 1130n minus 1130. So to find that nth formula, I usually write it in slope-intercept form. So I'll write the $1,130 n plus whatever 44600. Combine these two like terms minus 1130. And that would be 43470. So this is my answer here. So if I plug in 1, it's this 1130 plus this, which would give me this. What this would be is a y-intercept, and that would be at year 0. So that would actually be what this would be in 2001. Okay, but 2002 would be after you plug the 1 in. Now, they want to know how many years, how much will they earn on average in 2012? So I'm not going to plug 2012 in here because N are years after 2001. So in 2000, if 2001 is 0, 2002 is 1, what is the value of N in 2012? So N is just going to be 2012 minus 2001, which ends up being 11. So really, if I have this formula, I'm looking for what is the 11th a sub 11, the 11th term. So I'm just going to plug, it's explicit, so I can plug it in. 1,130 times 11 plus 43470. So 1130 times 11 gives me 12430 plus 43470 plus 43470, and I get 55900. So in the 11th year, a teacher's average salary is going to be $55,900. So you could take this right here, make a word problem out of it, but what I want you to do right now is try checkpoint 3. So we're going to get into the sum of an arithmetic sequence, all right? Also known, when you do a sum of a sequence, it's also called a series, all right? And the sum of an arithmetic sequence can be S of n is your first term plus your second plus your third plus dot, dot, dot plus a sub n. Now imagine having to add this sequence that is arithmetic. Well, there's a formula. If it's an arithmetic sequence, we can find the sum by simply applying one of these formulas here. Now, S of n is the sum of the terms. N is the number of terms. A1 is still your first term. And in this case, A sub n is going to be the last term. So we can apply this. This is the same one, except they put this over 1 and they just n times that over 2. All right, I tend to use this one a little more. So if I got to find the sum of this sequence, I'm going to have this formula. The sum of 100 terms, all right, is going to be 100 over 2 times. Your first term, I already know, is A1. And that's going to be 1 here. So it's 1 plus, and what's your last term? Well, maybe some of you can look at this and kind of figure it out. But if I want to find the 100th term, well, then I'm going to go to rewrite my explicit formula. So I got to do a little scrap work before I finish this. A sub n is A1 plus n minus 1 times d. Well, d, if you recall, is your second term minus your first, which is 2. Your third term minus your second, which is still 2. And if you look, you add 2. So I already know d is 2. I also know that A1 is 1, which I already had. And I'm looking for when I'll write my explicit formula first. So A sub n is A1 plus n minus 1 times 2. So A sub n is 1 plus 2n minus 1. So that ends up becoming, minus 2. Got to distribute right. So that's 2n, and 1 minus 2 is negative 1. So now I want to find the 100th term. What is the 100th term in the sequence? So that's 2 times 100 minus 1. So 200 minus 1 is 199. All right, so I was able to find my 100th term, 199. So that is my last term here. So now I know that A sub 100 is 199. So this becomes A sub n. Now I do A sub n, but remember, n is 100. So you're looking for A sub 100 is 199 plus 199. So if I did this, this is 50 times 1 plus 199 is 200, which ends up being 10 with 3 zeros, 10,000. And that would be my final answer to this checkpoint, this example number 4 right there. All right, any questions? Good. So try checkpoint 4. In example 5, we have to do the summation here. I want to find of this sequence 5i. Now remember, I is a variable here. It's not the imaginary unit I. It's a variable in this case. So when start from your first term and go to your 25th term. So what that tells me is they want me to add 25 terms. It's kind of crazy here. All right. So the amount of terms is not 24. You don't subtract. You subtract and add 1 because you got to go. If I said what are the numbers? How many numbers are there? 1 through 10. You're going to say 10. But if I did 10 minus 1, I get 9. But you got to add 1 for that number that you start with. All right. So there are 25 terms here. So you would do 25 minus 1 plus 1, which is just 25 terms. So there are 25 terms here that I got to add. And when I start with 1, that's going to be 5 times 1 minus 9. Well, that's 5 minus 9, which is negative 4. Plus, so this is my first term. And now I'm going to add my second term. 5 times 2 minus 9. All right, so that's going to be 10 minus 9, which is 1. Okay, not so bad. 5 times 3 minus 9. So that's 15 minus 9, which is 6. All right, 5 times 4 minus 9, which is 20 minus 9, which is I'm adding 11. I don't know why I didn't need to put parentheses here, but I did. So I get to this point where I'm like, listen, this is a line. I already know that this is going to be an arithmetic sequence. And what are you going up by here? Well, D is 1 minus a negative 4, which is 5. D is 6 minus 1, which is 5. D is your fourth term minus your third term, 11 minus 6, which is 5. Your common difference is 5. You're adding 5, which is the slope of the line of the sequence right there. So maybe I can use a summation formula. S of n is n over 2 times your first term plus your last term. So since I'm finding the sum of 25 numbers, that's 25 divided by 2. My first term is negative 4, but I'm not going all the way out to my last term, but I know what term it is. They give me the explicit formula right there. So if I just did this here, plus dot, 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 what would it be if it was 5 times 25 minus 9? Well, that's going to give me 125 minus 9, which ends up being 116. So I already know that my first term was negative 4, and my last term is going to be 116. So I'm going to add 116 there to kind of make that a little easier. So when I take a look at this, negative 4 plus 1, well, this is going to be 12.5. Now, when I see a decimal now, like 0.5, I'm like, wait, I shouldn't get a decimal. I'm adding integers. I should get an integer answer. Well, this ends up being an even number, which will eliminate that decimal. Once you multiply 0.5 to an even number, it's like taking half of something. It's got half of the even number is always going to give you a positive. And this becomes 112. So 12.5 plus 112 is plus 112 times 112 gives me a sum of 1,400. Now, just knowing this, that this was a line, I could have kind of skipped all this, found the first term, found the last term, because that's really all I needed here was the first and last term. I still need to know how many terms there are, which was 25. So remember that you're going to subtract, whatever you do, you subtract and add 1. Now, there is a button on the calculator that does this. So if you take a look here, you can hit the math key, and you can turn this, go all the way down to summation, which is right at choice 0. Hit enter. And it does give me this right here to fill in. Now, it uses the letter I here. Listen, I'm just going to use X for the variable. X equals 1, and then hit the up arrow key to 25. Now, the only thing here is since I used X for I, and I wrote it this way, X equals 125, then it's got to be 5X minus 9. You got to put an X there because that's the variable that you put on your calculator. And you could go 5X minus 9, enter, and it will give you 1,400. Now, you don't want to rely on this calculator because you're not going to have this in calc, but it could use check your work. Plus, In addition to this, sometimes this is not arithmetic, or we might be looking for what term would give me this sum. All right, and that's where we want to know this formula to use. But give it a shot. Try checkpoint 6. Now here goes an application word problem for example 6. Your grandmother has assets of $500,000, which means her house, her car, her everything she owns. That's what she has, what she could sell, and that's the money she has available at her age. One option that she's considering involves an adult residential community for a 6-year period beginning in 2009. So in 2009, she wants to move into this community. This is the model that they gave us. So the model is the equation that we're going to use, where it describes yearly adult residential community cost. So it's what it costs to live there, and years after 2008. So in 2008, this is what it costs to live there. All right. But she's not moving into 2009 where n is going to be 1. All right. So that's going to be 1 year after 2008. So does your grandmother have enough money to pay for the facility? So can she live there for 1 year? She wants to live there for 6 years. All right. And you got to think of it costs a different amount every year. So this is what it cost in 2008. This 1800 is actually your common difference, what it's increasing by every year. So it's not just the first year, it's not what it's worth the 6th year. Is $500,000 enough to cover all 6 years? So I'm actually dealing with the sum of an arithmetic sequence. All right, because you got your first year plus your second plus your third plus your fourth plus your fifth plus your sixth. And if you want to figure out all those values and add them together, that's fine. But what if I said 30-year period? Hopefully she makes it for 30 years, but then you want to know these formulas. So it's n over 2 times the first year plus the last year. So I want to find a 6-year period. Does grandma have enough money? So what's the sum of 6 years? So it's 6 over 2 times, well, first I got to find out what the value of A1 is. And since they already gave me an explicit formula, that's going to be 1800 plus 60 times 1, because that's your n, plus 64130. So 1800 times 1 plus 64130. So the first year in 2009, it's going to be $65,930 to move for the first year. Then I want to figure out what it is in the last year, your 6th year. So what's the value of the 6th year? So the 6th year, I'm going to plug in 6. That's 1800 times 6 plus 64,130. So 1800 times 6 plus 64,130 ends up being $74,930. So I'm going to take A1, 65930, and add it to my 6th year, my first plus my last, 74,930, and kind of calculate the sum. So 6 divided by 2 is 3 times 65,930 plus 74,930, and I get 140,860. And then I'm going to multiply that by 3 and get 422,580. So obviously this is less than what grandma has available in her assets. So yes, grandma could stay for 6 years. Grandma can stay in this place, can stay for 6 years. All right, that's what the question is asking. Is this 30-year period good enough? When would grandma have to get kicked out and moved in? I don't know. But the question was, can she make it for 6 years? And yes, she can. Try checkpoint 6. All right, we are done. I will see you next time when we start checkpoint 10.3. Take care, guys.